Hello everyone and welcome to my video on integration by parts. Now it's weird, I'm 147 years of age and I can guarantee you there's very little I remember in life, including what I had for breakfast this morning, which is weird. Oh no, Wheat Bix. Always have Wheat Bix. Too much information? I thought so. Now, this though is one of those things I remembered when I was back in the UK doing A-level maths. I loved integration by parts. It was great. And weirdly, when I came over to Australia, it wasn't really on the syllabus, but good news, it is. Now, my name is Darren from Maths Guru. You already know this because you've probably been watching my previous videos. If you haven't already subscribed, if you could do so, that would be massive. Why? Nobody watches maths content. You know what? I looked at one of my videos yesterday and in total it got 93 views. It's one of my highest ranking. It's weird, isn't it? Why am I doing this? Well, it's for people like you who are watching and hopefully will spread the word. One day I'll be famous. Okay, now behind me, I always put my learning objectives. What are we going to do? Understand where the integration by parts formula comes from and know how to apply the formula to questions. Now, the great thing here is previously we've been able to differentiate, terms or, expressions like that, x times e to the x, by using the product rule. We love the product rule and the chain rule and the quotient rule. These are all great for differentiation. But when it came to integrating something like that, we'd actually have to scaffold something called integration by inspection, which methods units 3 and 4 used to love. All right, it used to be a question on there all the time. And I used to love it. It was like, okay, guys, this is formulaic. Do this, do this, do this. Oh, look, guess what? There you go. You're done. But thankfully now, in specialist maths, at least you are allowed to use integration by parts. Now, the good news is anything you can use in spec, you can use in methods as well. So it sort of gives you a little bit of an advantage. Unfair? I'm not going to comment, but maybe a little bit. All right, now, if we go back to the product rule, we know that the product rule can be expressed in two different forms. A nice and easy one to remember, the one I learned in the UK, which is y dashed equals uv dashed plus vu dashed. Yes, that's the one I always remember. Or the one that's in the textbook if you're following the Cambridge textbook, which is that one there. Pretty much the same, whereas, v dashed is dv by dx, dx, and u dashed is du by dx, okay? Now, we're going to use the second more complicated case because it sort of makes life a bit easier. So let's take this here and say, well, what's now going to happen if we integrate all of those terms? We can do that. We know we've been able to do that because we do it previously. So moving to my next screen because all the hard work's already done for me. All right, so I'm going to take my original function here and I'm going to put an integrand in front of all of those individual terms. Okay, so using this, if we take this, which is basically just that, just moved over, I know, very exciting, and integrate each of those parts, which is this line here, we get this line here. Now you're going to turn around and say, hold on a moment, whoa, that doesn't make sense. It sort of makes sense if we follow it through this way. This, all right, the dx here and the dx there effectively cancel out when we integrate it, all right? So this and that has gone to give me just my uv. There's my uv. Now, obviously, I've moved it around a little bit. I've gone from there to there by jumping a step. Shouldn't have done that. Bad. What have we got here? We got u dv by dx. Well, this term here has basically moved to the front, and that plus has moved to the other side and become here. All right. So what we're now saying is, if we got u dv by dx, we can actually split it out like that. And you're going to say, this still makes no sense. Well, it sort of does now, because what we're saying is, if I have the integral of x, say e to the x dx, then what we're saying is here, let one of these terms be equal to u, much like we do for differentiation with the product rule. Let another one be dv by dx. Well, I've never thought of it as dv by dx. I don't like it like that. So what I say is we'll let that be v dashed. And then what it says is, to be able to do that, we effectively do the u times the v minus the integral of the v times the differential of the u term dx. Oh, all right. Now, again, these type of things sort of make sense when we actually work on them. And so let's look at an example. It's obviously much better explained in an example. So we're now looking for the integral of x cos x dx. Now, as I said a moment ago, one of these becomes u and one of them becomes v dashed, all right? Or dv by dx, whichever way you actually want to put it. Now,